that. That means you are searching for an angle within a specific region. When we do that, sine's going to be the positive value, first quadrant. Opposite is a root 3, hypotenuse is a 2. That means that's a 60 degree, otherwise known as pi over 3. Whereas, what is the secant of 240 means we just spin it to win it. You spin to figure out where you lie. Well, here, my reference angle is 60. Oops, sorry, that's supposed to just be 2. And secant is the inverse of what function? Cosine. So if cosine is, excuse me, if cosine is adjacent over hypotenuse, secant would be hypotenuse over adjacent. In other words, here, 2 over -1, your answer would be -2. Okay. So a lot of times people just forget what that meant. And they're like, wait, what angle has no secant? So just remember the differences, the subtleties within that. Now, on those last 3 pages of the 3 columns there, was there anyone? Oh, yeah! Loft house! You know what we've just missed? 159. What's today's date? We missed it. Anyway, so until next year. Was there anything on here that was just awful there? I mean, most people just forgot how to do that. And they went, oh, that's all I mean. Sir. Tangent -17 pi over 6. So first thing we have to do is figure out how many times does 6 go into 17? Twice, almost 3. And when we're spinning it, we know we have 1 little, 2 little pi's, 5, 6 more pi's. So my reference angle is pi over 6. Yeah. What do you mean? Well, the pi over 6 is a 30-degree angle. So then your opposite is -1, your adjacent is root 3, -√3, your hypotenuse is 2. So your tangent would have been 1 over root 3, or in other words, root 3 over root 3. So, like Nina was asking, and people were asking about with this stuff, save this, because we'll come back to a lot of the stuff off the front here and go over some of these things as we get ready to take our quiz stuff next week on Tuesday. All right? No, because what I want to do is I want to do a couple of the equation stuff, and we're going to start some of the equation things between. I figure it's a decent way to just go into the small part of the equation. Actually, one second. When you do the small equations with general solutions today, I'm sorry, regular solutions today, general stuff tomorrow, which is kind of the same thing. We can put everything together between Friday with a small amount of what are called identities, and then review all this junk together with this along with the equation stuff from Monday and do that. And then that'll give us Wednesday if people are sick, Tuesday to take it. And then we can start trig identity, like the whole on identity stuff right before break, which means we'll start very slowly and you guys will get very, very pissed and it'll be fine. It's great. I'll give you like 35,000 homework problems. No, we're just going to use do some identities. It's simplifying. It's just simplifying. It's like a puzzle. Guys, Lucy, what can I do for you? Mm-hmm. Which one? Okay, secant 495. So secant 495. Let's see. So I went around 360, and then I wound up over here, and I'm off by 45 degrees. So here's my 1, -1, and my root 2. So secant is the inverse of cosine. Cosine would be -1 over root 2. Secant would have just been you did the cosine, it just didn't invert it, I'm guessing. I bet you that's what you did for whatever the other ones was probably an inverse function. So hold this for right now because what we're going to do today, it kind of still uses the same premise of what angle has. And Ryder, you were kind of talking about this yesterday, or the other day you were asking a question, like, isn't sine also positive here? So what's going to happen is we're going to be able to take an equation and not just look for it within a specific section. When we solve an equation, we're going to have a couple of different new rules. For example, if I'm going to look at, can I skip over one? Oh well, no big deal. I'm going to look at, I'm not worried about this yet, something like this. I'm going to solve the equation 2 times the sine of x minus 1 equals 0. Yes, sir. This is technically 14.4, so it's all kind of mushed together. And what we're going to do is we're going to solve for x within a specific parameter. I'm going to find all values of x that satisfy that equation within one revolution. What that means is that I'm going to figure out what value of x makes this a true statement anywhere between 0 and 2 pi. So it being a sine value, if it winds up being a positive sine value, I know I'm going to look for whatever angle gives me that in the first and second quadrant. If it's negative, I'm going to look for angles in third and fourth quadrant, and so on. Sometimes you'll get 1 answer, sometimes you'll get 2 answers. We've had problems here in a little bit. We'll have 6 answers. It's just all working backwards from an equation, which you've all done. So if I see 2 times the sine of x minus 1 equals 0, what do you think the first thing you're going to do is? What do you think the second thing you're going to do is? Pretty good. So you know, as of right now, we're going to have sine of x equals 1/2. Now, in your infinite wisdom, which you have so possessed by now it being middle of March, actually not the Ides of March, what do you have to do to undo sine? Which we say, you're right, we call it the inverse. Okay? So your value is what angle has a sine of 1/2. Okay? Now, is that positive 1/2 or negative 1/2? Okay, where's sine positive? First and second. So here I know we have to go to my first quadrant. I'm figuring out what angle this is. I know it has to be an opposite of 1 and a hypotenuse of 2. What angle has an opposite of 1 and an angle or a hypotenuse of 2? 30. But notice my parameter is in 2 pi, so it means I have to write it in terms of radians. What's 30 in radians? There you go. So it's at pi over 6. And where else is sine positive? Second quadrant. Again, that gives me a reference angle of up pi over 6, which means this angle here is 5 pi over 6. Those would be the 2 solutions that are true for that equation. Yes, ma'am? Remember, we're using pi over 6 as the reference angle, how far it went up off the x-axis. So it means the reference angle will be the same in the second quadrant. So if this is a whole pi here, if I moved up 6, that means there's 5 pi over 6 to get to it. Reference angle. Remember when we talked about reference angles, how far you're bouncing off the x-axis? So if I'm up 30 degrees on one side, that means I have to be up 30 degrees on the other. 30 degrees up is you're coming from to be the terminal side, means you're starting at 0, coming over. What's that angle that has 30 degrees left to fall? 150. Same idea, but I'm talking about in terms of sixth. If I went up a sixth, means I have to be up a sixth on the other side, so I have 5/6 to come over. That was a different nomenclature, and that's where you have to be careful here. When we're solving equations, you're going to see this, which means you throw that out, and then unless you saw just this. If you see that, then you're just looking for it within that. But I'm solving an equation with this as its parameter. You don't worry about this. What you're going to worry about is all are positive, sine is positive, tangent positive, cosine positive. That's what you're going to look at. Okay? You're finding all. Remember how you asked what's going to happen when we have to find all the angles? This is what it looks like. Okay. There'll be a little slight difference when we talk about what's called general solution. We'll get to that kind of stuff tomorrow. Yes, sir. Hey, what do you get? Perimeter is what you walk around. Parameters are what you work within. I think so. Is that right? Parameters. Perimeter you walk with. Parameters what you work within. Whatever your parameter. That was pretty quick definition for me off the top of my head there. I'm pretty impressed with myself. Okay. And yes, as we go along, we will up the complexity. So yes, you guys will get increasingly upset with me, which is cool. I got big shoulders. I can deal with it. Excuse me. So we have 4 times the cosine of x plus 1 is -1. So this means what we have to figure out here is we got to get x by itself. So you work backwards just like you've worked backwards for every single time you've been in a math class since probably 3rd grade when you're solving for x. It just so happens that this just every year it gets a little bit more complex. What do you do first? Subtract the 1, then what do you do? So you get cosine of x is -2/4. Oops. Well, what's -2/4? -1/2. So I'm just going to shortcut and say it's -1/2. Now this means I need to solve for x. When I do that, I have to use what function? The inverse cosine. Good. So I'm going to ask what angle has a cosine value of -1/2. Okay. Which means I have to think about, all right, cosine is negative. Cosine being negative puts me 2nd quadrant to start. Cosine is adjacent hypotenuse, which means my adjacent is the -1, hypotenuse is the 2, my opposite is the √3. What reference angle is that? 60, perfect. If that's a 60-degree reference angle, that means I came up pi/3. Come over, your angle then, therefore, is? Excellent. So your one answer is 2 pi/3. Where else is cosine negative? In the 3rd quadrant. 4th quadrant, remember, you're going to the right, so cosine is the x, so it would be positive. But in the 4th quadrant, if I move down 60 degrees, I move down a third, it's still going to be your -√3/2, or excuse me, -1/2/2. If I add a third to a whole, how many thirds do we have? There we go. So your 2 answers would be 2 pi/3, 4 pi/3. Yes, ma'am. No, ma'am. Not at all. Not at all. You just have to remember which you hit them all. Now, this is why I kept saying that trig gets to be so unbelievably visual as you get into this. Being able to understand how you draw and work with reference angles is just super important with these things. And quite honestly, after we do this for a few days, you probably won't have to draw them as much. You might only have to draw one of them and go, okay, I know my replications, and go. But it's such a visual thing because you guys all understand where things pop and bounce around to. That's what we're doing. Okay. Men? Sir. We won't do that because your parameters are always going to be between 0 and 2 pi. So you're not going to be looking for negative angles. That makes sense? I don't think I ever changed that on you because that's kind of neat. Okay. Excuse me. So we have √3 times the tangent of x minus 1 is 0. What are you going to do first? Divide by 1, and then what are you going to do? Divide by the √3. Oh, did I say divide by 1?
Yes.
Jeez. you're screwed. If I divide by 1, would I screw anything up?
No. Yes.
Would I change anything? Okay. You guys all okay that you have to divide by the root 3? So if I divide by the root 3, here's the part that you're going to like. You don't need to rationalize this. Here's why. Because now, if you rationalize that, you get root 3 over 3. And then you'd have to figure out what angle has the tangent value of root 3 over 3, which means you'd have to unrationalize it anyway. So anytime you wind up with roots on the one side you're solving for it, in this case, don't rationalize them. It's easier to work with them. So we know this is going to ask what angle has a tangent value of 1 over root 3. Well, where is tangent positive? 1 and 3. Because tangent's y over x, you have positive or negative divided by negative. So if I'm looking at it, remember, tangent means opposite over adjacent. So here's our 1 and my root 3. Kind of nice when you can do it that way. All right. What angle is that? 30 degrees. Otherwise known as pi over 6. So if it's pi over 6 there, it means it has to move down pi over 6 here. So what's that going to be? Excellent. See how this is really combining everything we've been doing? You all right, Devin? You doing okay? Are you sick? Are you not feeling well? Or do you need help? I'm sorry, buddy. Yeah, don't give us a virus. Get it? Because you're on a computer? All right. Hey guys, this means sine of x times tangent squared of x equals sine of x. Okay. If you do that, you eliminate solutions. Remember how we did that before? If you had x's on, you got an x on both sides. You get rid of it, you lose the solution. So here's a hint. Here. If you had something like this before, when you had squared terms, we always had to set aside equal to 0 somehow. Because we have to be able to work in factor or take square roots and things like that. So when I see something like this, first thing I want to do is set one side equal to 0. How do I do that? Well, the easiest way is to subtract the sign. Okay? I don't want to divide the sign out, because if I divide a sign value out, I eliminate a trig function. I don't want to eliminate trig function, because that means I'm eliminating a possible solution. Okay? If I subtract out, I get sine of x, tangent squared of x, minus sine of x is 0. Do those two things have anything in common? They have a sign in common, don't they? Right? Factor that out. They don't cancel out. Watch what happens. Isn't this eerily similar to something like this? For lack of better, obviously a cube and whatnot. What would you do here? What would your solutions be if it was x times quantity x squared minus 1? Your solutions would have been 0 and plus or minus 1, wouldn't it? It's kind of the same process here, but there just happens to be more letters. Because now if you look at it, you've got two functions that are set equal to 0. You have sine of x equal to 0, and tangent squared of x minus 1 is equal to 0. So what I do is I set both of them equal to 0. And I solve them independently. Okay? Apparently they just saw the trig equation. They all got scared. Sine of x equals 0. That means what angle has a sine value that's equal to 0? Well, if you're going to get a sine value of 0, that means you're going to be on a quadrantal, correct? So sine is always, is it your x or your y value? It's your y value. Very good. So when we're looking at it, where is our y value equal to 0? 0 and pi. Okay. At 0 and pi, our values for sine are 0. So this equation works at 0 and pi. Radians? Yeah. The parameters that I'm going to give you will always be in radians, so I'm going to ask that you always give me solutions to this in radians. Now, the other part, you have to do a little bit of work. What do you think you got to do first? Add 1, okay. So over here, I'm going to take tangent squared x equals 1. How do you undo squaring? Square root. So what do you think the square root of tangent squared is? Tangent. What's the square root of 1? Or negative 1, because I did it over an equal sign. Whenever you take a square root over an equal sign, you have to do plus minus on the other side. Okay. No, that's generally frowned upon. So now you have the equation of what angle has a tangent value plus or minus 1. Correct. What's that? All of them what? It's all the quadrants. Very good. It's going to be in all the quadrants because tangent's either going to be positive in first and fourth, and it's negative in first and third. It's negative in second and fourth. But what's the reference angle for all of those? They're always 45, aren't they? So what's 45 degrees in radians in each of the 4 quadrants? Pi over 4. So we have one of them will be at pi over 4. 3 pi over 4. 5 pi over 4. And 7 pi over 4. You wind up with 6 total possible solutions to this equation. When you see plus minus stuff, you probably always wind up with 4 answers if it's asking you to solve for everything within 1 revolution. Because if you have sine squared of x is 1/2, that means where is sine equal to root 2 over 2 plus or minus every quadrant, that kind of stuff. You're going to see that with those. You could get 4 answers right off of that. Sometimes when you have some of these problems, you might just be looking for the positives. You might be looking for just the negatives. It could be looking for all of them. It just depends on the question. Get another one like that. Nope, that's not it. Gotta go back to it. You've done this problem before. We've done it? You're right. That's a very weird way of writing. The answer is 6. Do both those terms have something in common? What? Sine squared. So if I factor out a sine squared, I get a 2 sine squared x minus 1. You okay with that? Do I now have 2 terms that are both set equal to 0? So I set both of those terms equal to? Very good. Oh, I don't want to set them equal to 5 because 5 is not 0. It's 5 away from 0, but it's not quite there yet. So if it ever gets to become 0, then we can do that. No, that is you're getting ice cream. I'm not saying you're getting ice cream, but you know. No, you get pie today. Oh, I forgot it at home. Not happening. Anyway. How do I undo squaring? Square root. What's the square root of 0? 0. Okay. So this is going to be what angle has a sine of 0? Once again, you wind up on a quadrant. Sine, x or y value? Y, because it comes later in the alphabet. Cosine, sine. Your y value being 0, I believe, is at 0 and pi. One of the things you'll recognize, guys, you're only going to get so many different answers. So that kind of helps, smidge. Okay. And then on the other one, what do you have to do? Add 1 and then do what? Divide by 2. So I'm going to go ahead and write it as sine squared of x is 1/2. From there, what do? I take the root. So if I take the square root of that, what's the square root of 1? What's the square root of 2? So should I rationalize this? No. But what do I have to put in front of it? So x is equal to the inverse sine of plus or minus 1 over root 2. What angle does that occur at? Because I don't rationalize this because if I want to place this to figure out where it's at, sine is your opposite over hypotenuse. Correct. Yeah. When you're solving equations, don't rationalize because you don't need to. So that gives me what? My 45s again? Which means, hey Devin, I have the worksheet posted, and I believe the questions you have to do are circled. I hope you feel better. In this case, yeah. Apparently had a dog. And they slammed the door on the way out. And you get those 4 solutions for that equation. It happens. It happens. Más o menos. Let's try an inverse. If I use theta, does that change the problem any? Not at all. You'll see theta, you'll see x's, but remember, today we're only talking about within 1 revolution. So all of our answers are between 0 and 2 pi. We're not trying to go beyond that or do any of that other fun stuff yet. What? What do I do first? If you did that, you'd have to be very careful not to accidentally get rid of the 1 and the negative 1. You know what I mean? A lot of times when people divide that by 3, they're just going to write cotangent 2. See what I'm saying? And not to say you wouldn't do that, but what I'm saying is what I would do is I would treat this like I have every other equation. Subtract 3. then divided by the -3. Cotangent. Cotangent is the inverse function of what? Tangent. Here's a top tip. Reciprocal function, excuse me, reciprocal function. So, top tip. A lot of times when you have the reciprocal trig functions, it's a lot easier to rewrite them in terms of the standards, cosine, sine, tangent, and then by using the reciprocal. So the reciprocal of cotangent is tangent. The reciprocal of -1 is -1. This one isn't so bad because it kind of works itself out. This is the same exact problem saying what angle or tangent of theta is -1. Those two work the same. If it was cosecant and sine, I'd have to flip the fraction to get different results and whatnot. But for this case, we do this. So where is tangent? What angle has a tangent value of -1? Well, where's tangent negative? Second and fourth. It being a -1, that means that you have to have which triangle, a 30-60 or a 45? 45. So second quadrant, 45-degree angle, reference angle gives me 3 pi over 4. Fourth quadrant, reference angle 45 gives me, excellent. Just for argument's sake, these two values are how far apart from one another? They're pi. They're 180 away. But if I go from here to here is a pi, and if I go back, it's still a pi, isn't it? Does that ever change? So if I start at 3 pi over 4, and I add pi for times number or times around, won't I either wind up here or here? So if I say 3 pi over 4 plus 3 pi in, I go 1, 2, 3. Oh, there I am. If I do 3 pi over 4 plus 2 pi in, I'm back there. If I say 3 pi over 4 plus 11 pi, 1 little, 2 little, 3 little pies, 4 little, 5 little, 6 little pies, 7 little, 8 little, 10 little pies, 10, 11 pies, there I am. So isn't this a more generic answer than that? But doesn't this answer take us beyond one revolution? That's what you're going to miss out. The revolutions out, that's what you miss out on. You're not going, I thought you were going. I thought you were. Well, good, then you'll be here and we can talk more. What? Well, that's what we're doing. Tomorrow. I'm not going to be anywhere. This will be asked in a different question. One last one. One last one. And this is giving me a good example about the reciprocal functions. Five equals -3 plus 4 secant of theta. What do you think you're going to do first? Add 3 and then do what? So that means if I add 3 and divide by 4, what do we get? 2. Good. So I'm just going to write this is 2 equals the secant of theta. Now, I like to do things from left to right. Just because I do. Now, this is where I said that a lot of times if you have a reciprocal trig function, to rewrite it in its normal base. What's the reciprocal function of secant? Cosine. Cosine. So if I reciprocal this from secant to cosine, I have to reciprocal the 2 to becoming a. I always think that people see these values better when they are reciprocal into their standard forms. That's just my opinion. If you want to go through the other way, go for it. Not a big deal. But you'd have to remember that this is 2 over 1. That's really all you have to get at. So cosine of theta is equal to a half. That's the first quadrant. 1, root 3, and a 2. That means that's a 60. That's pi over 3. Where else is cosine positive? Fourth quadrant. So if I have a reference angle, if I have a reference angle of pi over 3, if I drop down a third from from 2 wholes, pi over 3. There you go. So, why is pi over 3? Because when I drop down to the fourth quadrant, I move down a third. And if I go all the way around, it's 6/3 for 2 pi. So I subtract 1/3 and I get 5 pi over 3. Okay. What? Did I miss something? Whatever. Hey, I must have handed a kid the problems to do, so I gotta look on the internet because I scanned a copy with the ones that I wanted you to do. I don't know where that copy went. So they probably stole it because you guys went. Or I could probably just look it up on the other assignment. You have it? Oh, all right, hold on. We got it. So it's on the first page, what is it? Second page? Third page? And then the fourth page? 5 and 10? Thank you. Sir? I do not have enough of these. Yeah, I know, but sure. I know. I ran off 75 of these. How am I short? What? What? Well, the country Texas is better than that. Sorry. I can't.
Can it? No. Think of it as negative x and negative 7x.